All right, this is your video that I've been promising on constructions. In this video, I'm going to go over how to create a segment bisector, how to create an angle bisector, and how to construct congruent angles, I guess, or congruent triangles when you're given congruent angles. So pretty basic. There's other things that we could have covered as well, like creating medians and altitudes. We'll probably introduce that later in semester 2, or earlier on in semester 2, but in the next semester. I just wanted to give you guys something to kind of be able to go back and rewatch. Okay, so we have a couple tools that we use in geometry sometimes. One is called a protractor. It's this guy. It's like a D shape, you know, ruler, whatever. I always want to call this a compass, but it is a protractor. And then for this, you usually line up against an angle you want to measure. Let's say I'm using this triangle that I just drew, and I want to put the little dot in the middle here, right on the vertex, and the side of my angle along the straight edge of the ruler, and this will tell me how big this angle is. It looks like this one is about 50, if not 51 degrees, right? This little angle right here. So it's a way to kind of measure angles. So we line up our straight edge with one straight edge of our angle, our triangle. We put this little point right here, right? And we line it up with one of the corners with the vertex, and then the other side goes right through whatever the degrees measurement is, okay? So that's what a protractor is for. What we're going to be using for constructions is this little guy right here. This is called a compass, right? And they can come big, small. I got this little metal guy, kind of a basic, it doesn't have a whole lot to it. There's not really a way to measure. Usually it has a little measurement tool and you can measure how far you want it opened up, if it's 20 degrees, 30, whatever. In this case, I don't have that, but I do like this one a lot. It's a metal one, it's nice. It has a pencil on one side, and then another side that has a tip, a point, but it does not write at all. Nothing about that writes. This side writes. Okay, so whenever we are creating segment bisectors, and you have at least an angle on a shape, some kind of polygon, whatever, what you want to do is focus on the two end points of your segment. So we're going to start off with segment AB right here, and I want to figure out a perpendicular bisector, meaning I want to figure out where is the line that exactly cuts this line in half and crosses that line at 90 degrees, right? So I'm going to take my compass and I'm going to open it up more than halfway. If I don't open it up halfway, when I start drawing circles, you'll see they're not going to overlap each other. So I want to make it, this looks like it's about halfway, I want to make it a little bit bigger than halfway. All right, and then on your compass, you can also tighten it so that your measurement doesn't slip around. However far you open it, doesn't matter degrees-wise, but you want to keep it open that amount the entire time you're using it, just to keep everything consistent. Okay, so then we're going to put the tip that does not write, we're going to put it on one of our endpoints of our segment, okay? And we're going to draw a little semicircle above the line, and we're going to draw, it's called an arc, and we're going to draw a little arc below the line, right? Kind of like this and this, and that might not be in the exact right spot, but we'll see in just a second. All right, keeping this the same measurement as I just had it, right? If I put it here, right to there, I'm going to put my tip on the other end point of the line segment that I'm working with, okay? And so I want to do the same thing. I want to draw an arc, a little tiny arc, and I want to draw one here. I want to try and figure out where they cross each other. That's my goal. Oh, did it open up more? No, that's right. It's kind of a weird shape. All right, so if I create this arc right here, so I didn't quite do my first arc in the right spot. I want to get them to cross over each other, so I'm going to redraw that first one. Make that one a little bigger. And for this other arc, this is the one that I wanted to redo. Make that a little longer. Uh-oh, my paper moved. Okay, so we've got these two little arcs right here. It's just like has a diameter, right? This measurement from here to here stayed the same the entire way. It's the same measurement from here to here. It's the same measurement from this endpoint to this arc, and this endpoint to this arc. So where these two arcs cross, we're going to put dots there. I'm going to start with green. I'm going to put a dot here, and I'm going to put a dot here. Okay, and I'm gonna find some kind of straight edge, a ruler, whatever straight edge you have, and connect those two dots. Now the arcs are no longer important. I'm just focused on these two dots, these 2 points of intersection. Okay, so now if you notice, this line segment AB has been cut in half. So this half is congruent to this half. And this bisector, this segment bisector, this line right here, crosses it at 90 degrees. It is a perpendicular bisector. So all we did was use our compass, create kind of a little measurement width apart here, right? Put our non-marking end on one point and made kind of, you could end up drawing like the entire big semicircle. You just don't need all this stuff in the middle. You only need right where they cross and right where they cross. But we did from this point here, we did one big semicircle. From this point here, we did one big semicircle. And where they cross each other, those points of intersection, those are the endpoints of our segment bisector. Okay, if that kind of makes sense. So we're going to do that for each of these sides. One thing I do want to do, though, is give everything a name, right? So this is my triangle ABC. I'm going to call these 2 points, I'm going to call it Z and Y. I'm going to work backwards, right? And I'm going to call this little dot right here X. Okay, so now I'm going to use a different color pen, but I'm going to do the exact same thing on side AC down here. Okay, so again, when I'm using my protractor, I want to make sure it's spread apart over half. At least half, if not more, a little bit more than half. If it's less than half the length of the line segment that I'm looking at, then when I draw these little circle arcs, they're not going to intersect each other. I want them to cross over each other. So I got to make it a little bit wider than half. That looks wider than half. Okay, so then I'm going to put my tip that doesn't mark here on A, and I'm going to do a little arc above my line, and I'm going to do a little arc down here below my line somewhere. I don't know exactly where they're going to cross. I'm just guesstimating. Same thing. I keep it the same width. I put my non-marking end on C, endpoint C, and I make my little arc, and I keep going, and I create my little arc down here. And I just need to see where the two lines intersect. Awesome. So they intersect right here, and they intersect right here. So I'm going to draw that line now. Okay, so that's another line segment bisector. This line that I just created, these two endpoints I created, they're equal distance from points A and point C, right? So when I draw a line to connect them, it bisects line AC, cuts it in half. This is congruent to this, and it's a perpendicular bisector, so it crosses it at 90 degrees. And just like I did here with X, Y, and Z, I want to label these points. So W, let's say this is W. This point right here is V, T, U, and this point we'll call it U. I'm going backwards through the alphabet. Okay, so again, these big messy like arc marks, they're not really important anymore. Once I figure out where they cross, then that dot where they cross is what's important. You can even go back and erase this stuff if you want to. Okay, and then for the last side here, BC, I want to come up with a perpendicular bisector for that one. And I'm just doing it just to show you guys how to do it, right? You don't always have to do all three sides. Just do whatever the directions tell you. Okay, so I've got my blue pen, do a different side. I want to make sure that my compass is opened up over halfway. Make it a little bit smaller. That looks like it's over halfway. So I put the non-marking point on endpoint B, and I do a little arc this side of my line, and I do a little arc. Oops. Did I just close it? Darn it, I pushed it closed. There, okay, now it's equal. And I want to do a little mark over here. Okay, and then so I'm going to put it equal distance from point C. Put that there. Do a little arc. I can see right where they cross. Awesome. Put a little arc this way. I can see right where those two cross. Sweet. So I put a dot here. And I put a dot here. And then I find a straight edge and I connect them. And this bisects line BC, so it cuts it in half. These two segments on either side are equal distance. And I'm at U, R, S, T. So I'm going to use points R, right here where it intersects. I'm going to call it S, and this endpoint, I'm going to call it T. Right? So my perpendicular bisectors here are Z, what letter did I use here? ZY, UW, and TR. Those are my 3 bisectors. All right? So let's do a couple practice problems, or practice examples here. Okay, so for a right triangle, that one was just kind of a random triangle, right? For a right triangle, we're not going to do all 3 sides. We're just going to pick a side and find the perpendicular bisector. You could do all 3 sides if you want. So I got my compass. I always want to call it a protractor. I got my compass, and I am going to find, for line EF, I want to find a perpendicular bisector. So I'm going to make sure that my compass is open to a little over halfway. That looks like it's a little over halfway down this EF. And I'm going to put it on the non-marking endpoint here on point E. And I'm going to make a little arc mark above the line and a little arc mark below the line. I don't know exactly where I'm going to need it. I'll find out here in a second. Same thing here. Oh, see, I made it too far up. One right here. And if it keeps going around, oops. Another one right here. So these did intersect. These up here I didn't quite draw it right. So I'm going to go back to E. And there. Just had to extend it down a little bit. Okay, so now I can see where those 2 arcs intersect. So I'm going to put a dot here, and then connect them. And that's literally it. Like, don't overcomplicate it. It's not anything super technically difficult, right? So this line I just created bisects this line that was already there. To segment this line I created that I constructed is a segment bisector because it cuts EF in half. Now this half is congruent to this half. And it's a perpendicular bisector. It crosses it at 90 degrees. Okay, let's do an acute triangle. That's when all 3 angles are less than 90 degrees. Right, so I'm just going to pick a side. Let's do GH, and I'll find a perpendicular bisector for that. I'm just trying different shaped triangles. There's no point in needing to do all 3 different kinds. I do want to make sure that it's open a little bit more than halfway. Do it about there. If you did it humongous, then when you draw, you're just going to draw this humongous circle, and your arcs will be really spread apart. And like I said, if you do it too little, your arcs won't overlap each other, so you won't know where they intersect. So you gotta do it a little bit over halfway. All right, so I'm gonna do one up here above it somewhere. Sorry, you see my fat fingers. And then down here below it somewhere. I say above and below because that's where it's at in my head, but side to side, I guess. And then same measurement. I'm gonna put it on point H. Oops, see, I didn't draw it in the right. Did I keep it the equal measure? Yeah, it's equal. Slid it. Be careful when you're like drawing that you don't slide this guy down here. Okay, so then I want to put it here and draw my arc and keep it there and see where this one intersects. See, I didn't quite draw that one in the right spot either. So they intersect pretty close together here. So here's a point of intersection, here's a point of intersection, and then I get my little straight edge, which I put off to the side, and I connect them. And that red line cuts GH in half, and it's 90 degrees. So this is a segment bisector. I created it from those measurements, right? Where this arc right here, that's equal distance from H, crosses over this arc, which is all equal distance from G. So they're equal distances from each other, and where they intersect, when I join those 2 points together, that line is a segment bisector, and it crosses it. It's a perpendicular segment bisector. So when you see a picture that looks like this right here, it's got these little arc marks crossing with a dot, these little arc marks crossing. That's what you constructed with or that's what somebody constructed with a compass. And so they might ask you, well, what kind of construction is this, right? This would be an example of I constructed this line because the endpoints are from these intersected points. I had to have a protractor, a compass to draw that. So I created this line, which looks like it bisects this segment. Okay, and then last one is an obtuse triangle, where one of my angles is a big fat more than 90-degree angle, right? And let's look at, just for the heck of it, let's go ahead and look at line JL. That's going to create a real big arc, but that's okay. All right, so I want to make sure before I start drawing anything that my compass is opened up what I think is more than halfway. So I think maybe like right there. That's big. So a line above it would be, oops, the page is going off the book here. Somewhere there, and a line below it, way out of sight. See, it's really big. The closer together you make this, the smaller your arc's going to be. Okay, so it looks like it crosses it there and there. Okay, so there's my 2 points of intersection. I'm going to put a dot. I don't know if it's this one or this one. This one looks rounder. I'm going to say it's this top one. I don't know, maybe it's not. Looks like this one kind of went flat, like I drew it wrong. And then down here, this guy. And then I need my straight edge again, which is where, oh, right on my left, here. Okay, so this line cuts this line in half. Kind of looks like this side is bigger than this side, but it's because this line gives you more room here, and this line is like right on top of this guy, so it kind of makes this corner seem smaller. But this line segment is the same length as this line segment, and this red line crosses it at 90 degrees. It kind of looks like a 90-degree angle, right? It should. All right, so if you have any questions on that, let me know. Those are segment bisectors. Now we're going to look at angle bisectors. I was drawing on top of it. You can see what I drew. All right, so we start off with an angle. Oops. Sorry, and you'll see on your test, they're going to ask you questions like identify the type of construction. This is what an angle bisector construction looks like. We've done one of these in the Q&As. I've posted about these before, but we're going to just do an example here. All right, so same thing. I have my straight edge of my pen ready. Have my compass. It does not matter how big you make this arc right here. It doesn't matter. So the first one, I'm just going to open it up a certain amount, and I'm going to create a big arc here that crosses over the top and the bottom of my angle. Okay, and so where that arc crosses my angle, those 2 points of intersection, those are important. I'm going to label those. So I'm going to call this one B, and I'm going to call this one C. Okay, so I'm going to take my compass. I haven't changed anything yet. And now, instead of having this point on A and drawing this arc, I'm going to move it to this new point I've created. And I'm going to try and figure out a point in the middle of my angle somewhere that's equal distance from this guy and equal distance from this guy. Okay, so I'm just going to, I know it's going to be somewhere here in the middle, so I'm going to try and just draw a little arc here, and then I'm going to use the same thing. I'm going to put it here and just figure out where it crosses that arc. Okay, easy peasy. So right where they cross, right here, you can call that whatever you want. Let's call it D, I don't know, point D. The arc part's not important, just that point where they intersect. So now I can draw a line, a straight line, from my vertex through that point in the middle. Okay, so what is this construction a picture of? What type of construction is this? Well, to know what we created with our construction, because sometimes when you're looking at a picture, you're like, okay, well, what was already there and what was drawn in later? I can't tell. The stuff drawn in later had to come from these little rounded arcs, right? So the angle was, the angle was there. To create an angle bisector, we first had to come up with this arc, and then those 2 points of intersection. And then from each of those points of intersection, they're both equal distance from A. I had to come up with a point equal distance from each of these points that was in the middle. So I drew an arc equal distance from B. I drew an arc equal distance from C. And where the two arcs overlap, that point right there is exactly in the middle of my angle. So when I draw a line from the vertex, which is in the middle, through that dot, that point of intersection, which is in the middle, this line is an angle bisector. It cuts my angle in half. So this side of my angle is the same size as this side of my angle. If this was a 40-degree angle, it would be cut into 20 and 20. Right? So let's do another one. This is with a right angle. Same exact thing. No difference whatsoever, no exceptions. It's how we do it. So we're going to put our compass that I keep wanting to call protractor. We're going to put it the non-marking point here on the vertex, and we're going to just create one big arc because I got to find both points of intersection, and the size doesn't change. Oops. Okay, so I'm going to put a dot here and here, and then put my non-marking endpoint. Is that equal distance? I feel like it got smaller. Oh, it is. Okay. My mind's playing tricks. Then I put my non-marking endpoint on the new point of intersection instead of on the vertex. Now it's here. And I'm going to create a big arc here. And I'm going to do the same thing on this one. And create a big arc here. And you can make your arc as big as you want, but it's only going to intersect in one spot, right? So we know the point of intersection is kind of going to be in the middle somewhere. So it's right here. So then to draw my angle bisector, I draw a line from that dot I just created to the vertex of my original angle. And you can stop at the dot or keep going. That part doesn't matter. That was not through that dot. Well, it's supposed to be. Anyways, you can pretend. So now this line that's supposed to be going through the middle of this dot bisects this entire angle. This is a 90-degree angle. Then now this is 45 and this is 45. They're the same. Good? Makes sense? Hopefully so. Pretty easy, pretty straightforward. Last piece of this is a construction showing congruent triangles. I kind of drew that too big, sorry. All right, so it starts off, you start off with two angles that are the same size, right? And this is very similar to how we constructed our angle bisector. You're just going to open up your compass a certain amount, doesn't matter how much, and whatever that amount is, it's not going to change when I go from shape to shape. So I'm going to put the non-marking point on my vertex, and I'm going to create a big arc, right? And I'm going to actually do the exact same thing here. It's still the same width. It's still the same size. So I'm going to create this big arc. Okay, so I've got two arcs now. So for this guy right here, and I told you where you're going to start with these angles started out the same size. So let's say it's a 30-degree angle here and a 30-degree angle here, right? Let's just say. I'm trying to draw congruent triangles now. I started off with one angle. Now I want to create a triangle. So this point of intersection and this point of intersection are going to be my new vertices, right? My other two corners of my triangle. So I'm going to draw a straight line to connect them. All right, so I know this angle is the same size as this angle. I know that the distance from here to this is going to be the same as the distance from the one I'm about to draw here. Let's go ahead and do that. This point of intersection, straight edge, draw your line, right? So these two triangles, and really they're supposed to be labeled like A, B, C, D, E, F, right? Triangle ABC is the same size as DEF because this length right here, this measurement was measured from my compass. It's the same length as this guy, which is also the same length as this distance, right? And this distance. And we know that this angle's the same. So now we know this triangle is the same size as this triangle, ABC and DEF, because side, angle, side. And side, angle, side. They're all the same length, right? So from that one arc of my compass, I can create two, just starting with one angle, I can create two congruent triangles. So if you see a picture that looks like this, an arc was created, out of that arc you created a triangle, right? The two angles you started with are the same size. This is an example of constructing congruent triangles. That's all you're doing. So if you see a picture like that with two of these arcs involved, this is just congruent triangles. I could do another example, but it's going to be literally the exact same thing. And with constructions, there's no numbers involved. It's just physically finding midpoints using that compass with the measurement, the same measurement you're using over and over from different areas, right? Finding where the two arcs overlap, finding that point of intersection. You're constructing lines from that. That's why they're called constructions. But the actual sizes don't matter, just whether or not the lines are in the middle or not, which they will be using a compass. Okay, if you have questions, let me know.